Good evening, ladies and gentlemen. Uh, Thank you, everyone, to join us here tonight. My name is Luis Piazet. I'm a journalist and writer. I like to write and I like to speak, but my role here is very small. I'm happy to present two great social actors that I just met about a month ago, I think. They are great people, and we are all social actors playing a single role or single play on this blue planet. So my role is very small, but I will make a very, very quick statement. Two statements. First, thank you, Oceanario, for letting us to present these two social actors here. One of them will present a huge problem that we all already know, but she will go over. And the other actor, social actor, will discuss solutions for this big problem. And Ines Boujmil. I have a difficult time to say her last name, from Tunisia. She is ambassador of Blue Med project and has a big title. Uh, Earlier career ocean professional and fisheries environmental engineer. That's a big thing. And she has more than that on her shoulders. And Gianni Valenti, a big fellow here from Paris. He's the founder of and CEO of GAIA's first organization, and he cleans the ocean. That's what he does. And beaches, that's a lot. And he has an innovative project to present to us here. So, enough said. Ines, please introduce yourself comprehensively and tell us what about garbage, your knowledge and statistics and data. Okay? I'll try to interrupt you several times.
It will
I'll
be a
try
pleasure.
not.
It will be a pleasure. Well, you already introduced me. Thank you so much. But I would also like to add that I'm an early career ocean professional. So I will be happy to share my knowledge, and I am also open to learn from you while interacting afterwards. So yeah, I will be starting by saying that plastic pollution has grown into an epidemic, actually. And plastic is everywhere. It is in our air, our water, and in our soils. So it is the vehicle for globalization and the epitome for an unregulated late stage capitalism. So it's a system that externalizes costs to people and the environment for the sake of profit. So we are only just beginning to understand the danger and the effects of our global reliance on this material. And what makes plastic useful is exactly what makes it harmful. So it persists. And we as species are contaminated with plastic, and not just by consuming it indirectly, consuming food or eating mussels, clams, or fish. So recent evidence showed that nanoplastic bioaccumulate in fish mussels after and cause DNA damage after a chronic exposure. So this is something. And yeah, so plastic pollutes at every stage of its life cycle, from when the oil and gas are extracted to produce it, till all the way to the end of life, where plastic waste will be littered, landfilled, or incinerated. So So yeah, we will be also having differences.
Well, Ines, I'm a sailor, and I used to, and I like to dive. And we used to tend to see the ocean as a flat surface from the top, but at the bottom it's completely different. Okay, I have been sailing
Exactly.
in Australia, United States, Brazil a lot. How the surface of the sea impacts or are seen from your perspective
Yeah, that's a
into
good
this one.
yeah, that's a good point actually, because when it comes to marine plastic pollution, millions of tons of plastic are enter the ocean every year. So they are carried by rivers, discharged by drains, dumped or lost from ships. So bathymetry plays a major role in litter distribution. Actually, I can give you an example. So, when the seabed is gently sloping, usually litter is concentrated close to the coast, and it will be near the main sources like cities, beaches, or rivers. And conversely, if the seabed slope is sharp, so litter will be conveyed at high depth and will be accumulated far from the coast. So there is also a difference between sandy and rocky beaches and seafloors. So I can highlight the example of the Mediterranean Sea. When the seabed is rocky, we will have fishing-related items more common. And while we will be having a sandy beach, so I said the rocky beach, right? Yeah. And while we will be having a sandy beach, litter is more common. So this is also a difference.
Right. And for instance, from your study, your research, you find more garbage on the column of the water at the bottom, or just following the currents where they are mostly the garbage,
Yeah.
sitting on the floor or navigating or flowing, because this.
Yeah. Yeah, that's a good question. Actually, we have submarine physiography, we have geomorphological heterogeneity, and seabed type, which play a crucial role in the distribution of seafloor litter. So I can highlight the example of submarine canyons. So these canyons act as conduits for dense water masses from the continental shelf to the deeper waters. And they are also, they behave like vectors for low density marine litter, which will then accumulate in the deepest canyon reaches. So, more generally, seafloor depressions promote litter accumulation.
And I know you brought a lot of data regarding the Great Pacific Patch and other patches of garbage spread all over the, the oceans. Can you go over and present that big data for us, please?
Yeah, actually, before going into this, I also wanted to highlight the consequences of these plastic pollution on the sea life and how it also contaminates our water. And then I will be moving forward to explain the different dynamics, how they could form the plastic and garbage patches, if I may. So, regarding plastic pollution, we have chemical processes, mechanical abrasion, and photodegradation through sunlight and ultraviolet light. So they gradually degrade the plastic floating at the surface or near the surface, breaking it up into smaller and smaller pieces. So we have fish in birds that are directly exposed to the dangers of floating plastic as they get entangled in it or mistake it for food. So packaging, especially rings and strings, are particularly hazardous. We also have many harmed species and endangered species. We have a long list of EUC and red list of endangered species, mentioning that 54 of species of marine mammals eat plastic garbage or get got caught up in it. So yeah, an important information is that since 84% of the plastic found to have at least one persistent bioaccumulative toxic chemical. Animals consuming these debris are also ingesting the chemicals attached to the plastic, and toxic substances like PCB or DDT accumulate in the floating plastic. So animals ingest not only the chemicals attached to the plastic, but also the harmful substances, toxic substances that are associated and accumulated in it. Yeah, I can also talk about the water contamination and then follow talking about gyres and garbage patches. So we have also ocean currents that may transport chemicals deriving from the decomposition of debris. And yet there are more important problems related to plastic, as floating plastic may also transport invasive species. So they are a danger and a threat to marine environment, biodiversity, and the food web. Yeah.
Well, I don't think you brought this, but since your job, I'm curious. It just became now. How you got this all this data? Tell us a bit. How was your work? How long took to get to this point? Because I know now you're gonna jump to the very big problem of Pacific patch and other patches. How was the work of getting data together and before analyzing them? Your team, how long it took to get to this point to see which type of garbage does this and that? Tell us how was your behind the scene job, how you have done this,
Yeah.
and how long?
Yeah, actually, I'm also being a fisheries engineer. I'm also involved in physical oceanography, and from physical oceanography, I learned that marine pollution is dynamic. So it's not only in one hotspot; it moves all around the oceans. And I can also relate this knowledge to the gyres that are also transporting garbage patches all over the ocean. So I remember that we spoke recently about gyres, and you told me about the twin gyres. So yeah, the gyres, we have actually two gyres. A gyre which are moving clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. So a gyre is simply a rotating current system that is comprised of the Earth's rotation, and it is also coupled with currents and prevailing winds. So it is essentially like a massive vortex in the ocean. And these rotating ocean currents, actually called gyres, form what we call garbage patches. So you can think of them like big wire pulls that pull objects in. So yeah, marine pollution is dynamic. And with a special focus on the Mediterranean Sea, even though we don't have gyres. But the marine plastic concentrations are pretty comparable to the ones of the garbage patches. So yeah.
Well, now tell us
Yeah,
the size of the problem.
exactly.
I know you have that figure there.
Yeah, well, actually, we have a lot of gyres. We have five gyres in the ocean, main influential gyres. Namely, we have the North Atlantic gyre, the South Atlantic gyre. We have also the North Pacific gyre, the South Pacific gyre, and the Indian Ocean gyre. And when we talk about garbage patches, it is well known that the largest garbage patch in the world is the Great Pacific Garbage Patch. So its size like three times the size of France. And this Great Pacific Garbage Patch have been studied. We scientists have studied this garbage patch, and it was known that more than 75% of the garbage and debris found are of debris greater than 5 centimeters in the size. And we also have around 46% of the debris from fishing nets and gears. So this is mainly the most important garbage patch. We also have a lot of garbage patches related to the gyres, but yeah, I wanted to focus on this one.
Well, thank you, Ines. Okay, I think we are going to jump to my fellow here, Gianni Valenti, before questions from the audience, unless someone has a question right away to Ines particularly.
Yeah, maybe I could also
Okay. Oh,
yeah,
you want to add
close
something?
a
Yeah.
bit.
Okay.
Good. So if I have enough time to say a few words, maybe before the. Good, good.
Go ahead.
So actually, I was also thinking about what could happen if nothing changes. So you can just think about it. The more plastic we make, and the more oil and gas we need, the more we exacerbate climate change. So tackling plastic production through the value chain is a must. And this is not only the problem, actually, because we have a lot of problems related to plastic pollution, which is a snowballing effect. So we have the ineffective waste management. We have dumping, shipping to Africa, to Latin America and Asia, and so on. So if we want to turn off the tap and just try to make a change, everyone, including governments, businesses, NGOs, and people like you, will have to make some meaningful changes. So we are the problem, and so we must also be the solution. And thank you.
Thank you, Ines, again. Thank you. Gianni Valenti, let me ask one private question here. Nobody's hearing. You used to be investor, you gave up to clean the ocean, and now you are asking funds to clean up the ocean.
Well, yes, because I think the ocean is very important for not just future generation, our generation actually. And so we have to stop just talking about it and doing things. And to do things, you need money. And money, there is money going around. Obviously, money is given for other, business interests. But we have to remember that the ocean is the sustaining of all kind of life and all kind of activities. So any investment in the ocean actually will reflect on every other kind of business. But thank you very much, Ines and Luis. This is actually very important what Ines said, but what we must understand that with the problem with microplastic and the plastic in general is just plastic, as you very well said, absorbs chemicals, and there's a certain type of chemical that is absorbed, and this is the hydrophobic chemicals such as neurotoxins, neurotoxin like insecticides. So what happens is that as plastic fragments itself and becomes smaller and smaller, it becomes a perfect vehicle of those neurotoxins to enter living animals. And we have found microplastic in our blood and in placenta. So this means that we will also have potentially neurotoxins in our blood and in placental fluids. And the problem is that when the plastic is at the microscopic level, microplastic or nanoplastic, there's very little that can be done because you cannot, not very easily and not feasibly, you can collect it and eliminate it. So what we must do is we must act while it's still big. And Luis, there is 400,000 tons of plastic floating on the sea. 400,000 tons of plastic, which is a time bomb. This plastic will eventually fragment itself and be everywhere. So if now we're finding it in our blood, soon we will find it a much higher percentage if we do not do anything with that. Obviously, we have to tackle we have to avoid new plastic entering into the oceans. For example, from streams, from production, from waste management on coastal areas. And we have to rethink on plastic production and limit it. But we have to do something with the plastic that is accumulating in the garbage patches.
The ones already there.
The ones that is already there, because that is going to fragment. The longer we wait, the more it will fragment, and that's a time bomb. There's nothing that we can do. We have to act now before it's too late. So this is exactly what we're doing. You see, what the present ocean. Sorry, I've got my notes here flying around with the wind. But
Put a nice point
Yes.
there. While we are cleaning, we are showing an attitude. We are showing a sort of a state of mind.
yes,
But we also are cleaning for effect.
yes,
We need to clean. And you
Exactly.
have a way to dig it out the
Absolutely.
from there.
Now, we're here, I hope we're not the only ones, but meetings like this are important to showcase the problem, but we also have to showcase the solutions. And we have a solution. Okay, now GAIA First, it's an NGO. We're based in Paris, but we're acting internationally. And we're piloting probably the largest ocean cleaning operation in the world by designing ships that are able to go out in the open ocean, collect the garbage of the garbage patches, and transform it into green energy directly at sea. In order
adapting
to
ships.
use, sorry,
We're adapting ships or building ships.
we're adapting ships so that we can produce the green energy essentially in the form of green hydrogen, and so that we can use this green hydrogen to alimент the ship itself in a self-sustaining way. Now, this is the only sustainable, feasible, and environmentally logical way to tackle those garbage patches. You know, you see, currently, the current methods at best, it's been estimated if we use other groups' systems, we would need 130 years of operating just to clean up one patch at the cost of 36 million euros per year. And that's not feasible. Not feasible, we don't have the time. Because of fragmentation, we will not be able to collect anything in 10 years or maybe 15 years. And also for the money investment. So the only way this harvest and return approach that has been used, it's not logical because it also uses an incredible amount of fuel, carbon fuel. So the only way to tackle it is to produce their own energy by using the garbage itself. And this with a zero carbon fuel production, such as hydrogen.
These ships will be there doing this kind of work for all of us, and also can do something else while for researchers like have Inez on board and keep researching things, maybe fish. not
Absolutely.
garbage.
These ships will be seaborne for the whole time. So they will be self-sustained by the energy produced. They will be able to host oceanographers, and by marine biologists so that to study life at the high seas. What's important to understand is while we are cleaning up the garbage patches, okay, we will be like replanting trees because we will be reviving the natural photosynthesis of the phytoplankton, which lives on the surface of the water where actually right now the garbage is. So by clearing those areas, we're reviving phytoplankton, which would mean, if we're talking about the Great Garbage Patch, that by cleaning just the Great Garbage Patch, it would be the equivalent of replanting 400 billion trees. And we can do that with 2 boats at a 50 tons per day operation in just 5 years, okay, with 0 carbon emissions.
And this technology is something that already exists. You were the one that came up with a project, went ahead one step, and then brought in 2 companies
Okay.
to help you to finish the project.
Correct. Well, the technology actually exists already. It has to be adapted to the marine environment. And to do this, yes, we are honored to actually be working with the RENA group. It's a very big international group dedicated to marine engineering and development and optimization of systems. And we're also working with Breeze Ship Design because we have to design ships that actually can run on 0 carbon fuels and can adapt the system so that we optimize the energy balancing. What's important, we have to understand that this action in the oceans not only will have an action in favor of biodiversity and protection of marine life and reconstitution of the natural carbon sink of the ocean, as well as climate control, epidemic control, and everything related to the livelihood of the oceans. But this action actually will open up new opportunities in business, such as will contribute to 0 carbon sea shipping. It will contribute to waste management at sea. So this will be actually applied to all kind of ships. We will be developing units so that every single kind of ship can actually use their own waste to power their needs, as well as local communities, islands, and areas that have got major pollution problems in the shores.
Okay, what I was going to ask now is related to some news that I just broke up. A huge tourism German company went bankrupt, and they used to have the biggest cruising ships too, for 7,000 people aboard, and a third ship for 9,000 people was just about to be launched, so basically done. But they are now, they will need now to destroy that big ship.
Well, this is an opportunity for us. If they would like to support us, we can definitely discuss about this. We do need support. We are looking for support in all kind of ways. It's an incredible opportunity because we will be shaping future blue economy as well as restoring the current environmental status of the oceans.
So the stage of your project now is you are looking for a ship to be adapted and investor to jump in and finish up the R&D. You said
Yes.
Before or
Well, we're currently in the R&D phase, and we're looking for funds and support to finalize this stage. And if everything should run smoothly, and we are expecting by January, February to be able to start the modification on the ships, and then be operating at sea in 2024, June, July 2024. But yes, we're open to new opportunities and partnerships, whether it's for now or for the second phase, but we're open.
And if, for instance, if I am the investor, I don't have any money in my pocket now, how long I would get back my €1 here or €1?
Okay, well, we have to understand that this is an NGO. So what we are looking for now is support, like from philanthropic point of view, or a further view as as an investment for further developments. But currently, we are as an NGO. We will be discussing probable business cases afterwards, but we need support mainly as sponsorship right now.
So basically, is any kind of ship that you can have handy, you can readapt the project or adjust the
Well-
project and start.
Well, let's put first things first. We need financial support, and then the ship will come later. And we're talking about at least 80 meters, so they're quite big. Okay.
All right.
One thing, I just wanted to differentiate the importance of tackling high seas plastic pollution other than the coastal pollution. Coastal pollution, it's mainly made of packaging, and the waves and tidal effects actually might bring back to shore, to the beaches, that very pollution. The problem with the high seas, of which, as Ines said, 46% of it, it's from fishing gear, discarded and lost fishing gear, means that actually the pollution there will continue from one side to kill and to fish, to capture and to kill living fish, living animals, and at the same time, there's no way to collect it. So it will stay there and will keep on going until we get rid of it, or it fragments, and then we will find it, not just on our table, in our blood, in our children, and everywhere we look. Already we have found microplastic in the Arctic circles. So it's spreading. As I said, we have a time bomb on our seas, and we have to deal with it. Now, there's no time to waste.
I totally agree with you. Okay. Okay, we have a questions. Yeah. Okay.
Two and three.
Oh, beautiful, beautiful. From Shaker Al Maktar. Thank you. Plastic pollution is huge. It's yours? No? We are trying to educate and awareness fishermen and coast goers not to leave plastic waste. There is a great response that needs more follow-up, but financial support is lacking to continue these initiatives.
Yes, it's important to notice that although there's a lot of investment going on, as I said, investments seem to be more focused on business opportunities, which is absolutely fine. We have to make business to attract and motivate things, but it should not be just limited to. Actions like cleaning up the oceans by fishermen who actually work there should be promoted, because the beneficial effects, they're not direct, they're indirect. There's a multitude. So it's important.
Yeah, you step ahead very well, but Almakart asked the question then. Ocean pollution by plastic is due to plastic production on land and release from land-based sources. Why we don't stop and banish plastic production, at least for a single-use plastic? Definitely.
That's definitely one step. That's definitely one step. This is not the solution. This is one solution. It's a big puzzle. We have to stop single-use plastic. We have to redesign plastic, because plastic is useful. It's not a monster. It's useful, and current technology and current live status would not have been possible without plastic. But it has been badly designed, because we cannot recycle it. We can use it. We can upcycle it maybe once, and that's it. It changes structures. And we have to always reintroduce new virgin material. So definitely we have to reconsider the whole plastic production at an industrial scale, and also waste management at an industrial scale. And we have to check also waste. We have to keep controlling the waste, because sometimes from recycling plants it's not fully recycled. In fact, very little is recycled. So we have to transform the recycling techniques. And we're working with gasification systems. This could be actually a system that we could develop for the old type of plastic, breaking down the polymeric structure of the hydrocarbons into the essential forms, and then reuse them to remake other plastic, maybe, or energy, or water. So it's important to rethink and tackle it in different approaches, not just one approach.
Great, thank you. Ines, would you like to add?
Yeah, actually,
Please.
I wanted to provide some answers related to the first question. So the first question mainly related to ocean literacy, but it was mentioned that financial support is lacking. So I just wanted to tell you about a new mission Ocean 2030 launched by the European Commission. And this mission, actually, it's restore our ocean and waters by 2030, dedicated to 4 regions. So we can mention the Mediterranean Sea, for instance, where the objective is to reduce marine pollution. So this mission is huge, and it can support all types of projects, NGOs, and everyone who is working to protect the oceans and waters and achieve the objectives by 2030. So check it out.
Thank you. A last question, very quick. From Ryota, effect of toxic chemicals associated with plastics to the marine biodiversity. Any thoughts or evidence so far?
Well, this is exactly it. As I said, plastic acts as a sponge to toxins, and that's why we have to get rid of not just plastic. Well, we have to get rid of microplastic, and the only way to tackle it is before it becomes microplastic. That means let's get rid of the bigger pieces now. So it's important. All of you, I invite you to follow us on LinkedIn, on the Instagram, and on Facebook, and on YouTube. It's important, social support, because we need voices, we need your support, and that's it. We have to get quickly ahead. So thank you so much.
GaiaFirst.org.
Yes,
Thank you. Big hand for them.
Thank you. So just in case you want to know, it's GaiaFirst.org on internet. Instagram is Gaia.first, and then everything else is on the web. So thank you so much again.
Thank you again, everyone. Thank you, Gianni. Thank you, Ines.
Yes. Well, we have a question.
Yeah.
Thank you. My name is Sean Nazarani. I come from the Environmental Foundation Biofund in Mozambique. And I had a couple of technical questions for you. First of all, maybe for Ines, what percentage of marine plastic waste is ending up in these gyres in the first place? And then being a foundation that both has philanthropic funds and we're also working on having investment funds, why should anyone invest in cleaning up the gyres rather than stopping the plastic entering in the first place? That's related to the first question on the percentages on that. Thanks.
Yeah, that's really a good question. And I would answer by saying that it is complex, actually, to define the size of garbage patches or to quantify the debris, as this trash constantly changes its position related to the currents and to the winds. So, as an example, since spring 2020, another element has been added to the debris, which is used face masks and more single-use plastics. So that's really a good point, actually, because these garbage patches are moving in the oceans, and they are dynamic. We could tackle them to reduce the impact and the dangers that they are causing on the ocean level, at the ocean level, and we should also create synergies to tackle plastic pollution on the land and to stop it from sources. So we can detect many sources like rivers and discharges, and we also have to stop dumping and shipping waste. So more efforts need to be well managed to stop shipping the plastic waste. We have a lot of problems, but we need the collaboration of everyone, as I initially and previously said. So we need the governments, we need the business sector, we need NGOs, we need young people, early career ocean professionals, together having synergies to tackle the problem from the beginning and the source until they sink. Yeah, I hope I answered your questions.
I would like to add something. Yes, what percentage of trash actually goes into the jars? As I said, we have a different type of pollution. The origins of the pollution that we find on the near the shores actually comes from the land. The type of plastic that we find in jars, most of it comes from the shipping industry, as Ines said, and 100% of the shipping lost gears will be found on the gyres, unless they are collected. But the problem of collecting is that we're talking about a moving continent. It's hard to trace. And that's why we cannot do a harvest and return approach, because it would be delirious to just go and try blindlessly to hit a target, collect maybe a couple of tons and go back and do this millions of times. We have to be in the ocean, guided by satellite vision to check where the highest concentrations are, collect it and gather it. Why is it important? Why philanthropists should invest in it? I'm not saying they should do this other than blocking waste management or fixing waste management at the shores, but it should be complementary, because, as I said, we're talking about huge areas. One of them is the size of 3 times the area of France floating in the ocean. 3 times the area of France. Okay, it's floating in the oceans. If we do not tackle it, we will all feel the consequences in our daily life in a few years. We have to tackle it. There's no other conditions. There's no other way. And the very existence of this patch, of these patches, actually contribute to the heating up of the globe, because the oceans hindered, it's blocked. It cannot cool down the above temperatures because of this kind of blanket of plastic. On top of that, plastic actually absorbs the sunlight. Therefore, it actually increases even more the temperatures above the water. So there you go. If you want to regulate the climate, you want to do climate control, we have to clean the oceans. And the high seas oceans is one of the major areas that have to be tackled. Any other questions from anybody else? Yeah. Come over. You yes.
I have a pretty practical question, because you said that the hydrogen from the hydrocarbons, it will be used to power the ships. But what happens to the carbon part? Because you also said that it's zero carbon emissions. Thank you.
That's a very good question. Thank you so much for your very intelligent point of view. Well, you see, the actual carbon that we will be having left over, it's atomic carbon. It's in physical form. So what we're going to do is we're going to stock it, and then we're going to sell it to the industries to make graphite. Or what I'm actually thinking of is actually making sea diamonds, synthetic diamonds, on the ship to actually promote and sustain the whole operation even further. So your carbon will become nice jewelries in the future, in the near future. Any other questions? Please come over.
Is it working?
So I have a question, both of you. So you were talking about collecting garbage on the surface, which I hear. So, but I heard that the floating garbage, floating litter, like finally ending up in the sea floor because they can eventually sink down to the deeper water. So is there in any way to collect the debris on the sea floor? And also, I have a question about you, so you were talking about the seabed related to Mediterranean Ocean and also gyres. So I was wondering that if you go to the deep sea floor under the gyre, do you think you can find much more plastics on the seafloor? So I have two questions.
Okay, for the first question, I'll answer my part. So yes, the problem with the sunken plastic, there is a problem. Currently, we are not tackling that one. We can tackle floating garbage, and that's exactly what we're going to do. There's 400,000 tons of floating garbage right now. There's enough to collect. Certainly, the sunken plastic is a problem. We have to also say there will be sedimentation occurring. So in a way, we're blocking that plastic also from further microplastic degradation, but is not entirely the situation. But as I said, we can only, right now, we're focusing on the surface level.
Yeah, I can also say what Gianni was explaining. By tackling floating plastics, we can also prevent these plastics to sink and to go in the deepest oceans, because it costs a lot of money to tackle the benthic, the plastics in the benthic area, in the deepest oceans, and we need to stop this before it's too late. So mainly, floating could be an effective method to tackle tackling floating plastics could be more effective than going in the deep, because we will be having a lot of plastic pollution and marine pollution in general in the deep oceans, but it needs a lot of money, and yeah, I hope that we will be having perspectives in the future to tackle it, but let's start from the feasible method. Yeah.
Okay, thank you, Inez, again. Thank you, Jenny, and thank you, the social actors. We had a great time tonight. We made a great play, right? Thank you again.
It's time to act, not just to talk. So you're welcome to join me.